Okay, so we're going to continue our discussion on connective tissue. This is going to include the connective tissues that weren't included in the first set of notes. Okay, so the next type of connective tissue is hyaline cartilage. And hyaline cartilage helps support, reinforce, cushion, and helps with compression in between bones. It also forms the costal cartilage, so this is that cartilage that you see in that picture there that's shown in red. It actually attaches the ribs to the sternum. And it's also found in an embryonic skeleton at the end of long bones in your nose, your trachea, and your larynx. So it's kind of a flexible cartilage, but it's still pretty rigid and provides good support. Okay, so here's what it looks like in a slide. So the kind of things that you want to look for as you're studying this is how these cells, when they are up against each other, they kind of create this flattened edge in between them. So that's kind of characteristic of hyaline cartilage, so maybe something you want to look for. You'll also notice that there is not as much elastic fibers, which are those kind of dark purple ones that run through it, and you'll see a lot more on the elastic cartilage. So elastic cartilage is similar to hyaline cartilage, but with a whole lot more elastic fibers. So again, it's those kind of purple string-looking fibers that run throughout the tissue, kind of goes between the cells and all over. So this kind of cartilage is really good at being really flexible, but also maintaining its shape. So the outside of your ear, so the part that you pierce, the part that can move around, it's very soft, very flexible, but it always maintains its structure. It's also the same type of cartilage that makes up the epiglottis, which helps cover the esophagus or trachea when you swallow. Okay, so here's a picture of the elastic cartilage. So all those purple lines you see running around the cells and down throughout the picture, those are elastic fibers. So this can look similar to hyaline. So you can see with these two cells, they have that flattened edge. But with hyaline cartilage, you're not going to see this amount of elastic fibers. Okay, fibrocartilage, this is similar to hyaline cartilage, but less firm and with a whole lot more collagen fibers. So those are those thick bands. They provide a lot of strength. They are the cushions in between the intervertebral discs. So as you're walking and your back is being compressed, that's the discs, those fibrocartilage discs, helping to create that support in between your vertebrae. So here you can see the fibrocartilage. So these dense bands here, that's the collagen fibers that run throughout it. But you can also see those little purple ones that run through. Those are the elastic fibers. So this one has both. The cells, again, have that similar flattened look. But with hyaline cartilage, you don't see these elastic and collagen bands. Okay, bone is also a connective tissue. It's also called osseous tissue, and it's hard calcified matrix with collagen fibers that are found in the bone. The type of cells that are found in the bone are called osteocytes and are found in the lacunae and are also well vascularized, meaning there's a lot of blood flow there. And of course, bone helps us to support, protect our body. It's something for the muscles to hook onto so that you can move. It's an important place where calcium and minerals are stored. And also in the bone marrow is where hematopoiesis occurs, which is formation of blood cells. So bone is one of the easiest types of slides or tissues to recognize because it looks like the rings of a tree. And all those little black dots you see going around in circles around the rings of this tree here are where the nucleus will be found. So those are the lacunae, and inside you would find the cells of the bone. Okay, blood is our last type of connective tissue. It includes red and white blood cells. And blood is contained within blood vessels and helps transport gases and nutrients and wastes. Okay, so the red blood cells are the smaller ones, and you're not going to see a nucleus inside those, whereas the white blood cells are really big and purple, and those are a lot easier to spot, but they're not very numerous.